we are demonstrating an ORAN-compliant intent-based MANO framework for end-to-end network slicing, supervised by Professor Qianchao Sang, from National Yangming Chiao Tung University, presented by student Yihong Lin. This demo has two parts. First, we'll use an intent-based MANO to deploy an end-to-end network slice. Then, we'll verify the QoS of the slice to make sure the bandwidth and latency meet our expectations. In the demo, we begin by deploying the management components. These include a UI integrated with an NLP engine that allows users to submit high-level textual intents, an end-to-end orchestrator that coordinates SMOs across multiple domains, and the open-source project Nefio, which collaborates with the SMOs to deploy network functions. Additionally, FOCUM is used to deploy and manage the O-Cloud infrastructure. First, we use FOCUM to deploy 4 interconnected O-Clouds, where we also deploy IMS, the DMS for RAN and CN, and the TN agent. We then simulate network latency between them using Linux TC. Next, we submit a textual intent through the web UI. The NLP engine translates this into a QoS intent, which is then handled by the end-to-end orchestrator in coordination with each domain's SMO to deploy the necessary resources for the network slice. In the web UI, users can create network slices by simply entering a text description of their network requirements. The chatbot interprets the intent and automatically generates the corresponding QoS parameters, such as bandwidth and latency. Once the user confirms, the system proceeds to create the network slice based on these specifications. After a short wait, the network slice will be successfully created. In the Nefio UI, we can see that 4 clusters have already been deployed, including 2 edge, 1 central, and 1 regional. Additionally, we can see that 2 network functions are deployed on edge 01, 4 network functions are deployed on the central, and 1 network function is deployed on the regional. On edge 01, 2 network functions have been deployed, CU up and DU, on the regional. 1 network function has been deployed, UPF. In Web UI, we can then input different textual intents to create additional slices with varying QoS requirements and wait for their deployment to complete. After the slices are created, we can view them in the Nefio UI. Due to Slice 3's stringent low latency requirements, its UPF is deployed at edge 01. From the network slice deployment results, we can see that Slice 1 and Slice 2 have their UPFs deployed to regional clusters with more computing resources. In contrast, Slice 3, which has strict low latency requirements, places its UPF at the edge. We then connect an OAIUE to each slice and perform bandwidth and latency tests. We used iPerf3 to test the bandwidth of each slice and found that each UE's bitrate stayed within the limits set by the QoS intent. We measured latency using the ping command. Due to the use of simulated network functions, some baseline delay is expected. After accounting for the TC overhead, the latency of each slice stays within the thresholds defined by the intent.